Welcome back to the SRM workshop. My name is Tim. So today we're actually tackling a printer project that I've been in development for the last 3 weeks now. I've actually produced most of the mechanical components, all the mounting brackets and whatnot. And this is a prototype. We're going to do, I believe, a total of 3 printers. Maybe more, I don't know, depends on demand and whatnot. But basically the purpose of this printer is to have a larger build area than what you can readily get, and it's going to be significantly less expensive than what you can normally get. But because of the way it's being built, all the parts are off the shelf, easy to obtain components. So really anyone could build this if they had a little bit of time and whatnot and a couple critical pieces, but it's a reproducible printer. So what I'm doing, instead of the final printers are going to be have an aluminum frame, so that's actually already been designed, and now I'm actually going to, I took and pulled some dimensions off of my digital design, and now I got to go through and basically translate that to this really nice piece of oak plywood. And I didn't have to use oak, but I really like the grain structure on it, and it looks really nice when it's finished. So that's what we're doing for mine. Since mine's a prototype and I'm going to live with it, I'm going to make it look pretty decent. Anyway, but yeah, we have four main components. We have the bed plate, which, yes, it looks kind of an odd shape, but it'll look really cool when it's done out of the aluminum. It has an access hole that runs in between the 2 guide rails, and then it'll have a backing plate where all the electronics will mount to. You'll have a support for the gantry, and then a gantry plate that will be one solid piece. So this printer should be pretty rigid when it's all said and done. But yeah, we'll just start plugging our way through it. I'm going to move the camera down low and put it on time lapse because this is probably going to be quite a bit of time to do all the layout on this, and we'll get going.
Once I started laying this out, I realized that I should do the base plate and the smaller of the end caps on the same plane, and then the next section up I was going to do the back plate and the gantry plate, but then I came across a little bit of an issue.
Alright, so this is the point in which you realize that you made a grave miscalculation. I'm not sure where it is, but in I believe my frame design, I am off by 100 millimeters. So this edge here was supposed to end here, which again is a 100 millimeter difference. So either I miscalculated when I was measuring or something, so I gotta go back and figure out where the heck I went wrong. But unfortunately everything lines up this way, so yeah, there's that. Alright, so I figured out where I went wrong in my design. I got a plan to correct it. So basically this center line, which I established for the backboard, I'm going to shift that over by about 50 millimeters, and again there's some notches and stuff that are going to get shifted over, so this end will get extended 100 millimeters, and some of these other dimensions will change, but I'm going to leave this gantry plate intact, end plate intact, and the back plate all intact. So just got to work my way through it.
Now, just to be clear, there's no real reason to have the frame design be as complex as the one I'm currently designing, but it was one of those things where I wanted something that had a little bit of a visual appeal, not just being a square box like so many custom printers are. And then when we do the final aluminum version of it, I think it'll look really, really sharp laid out this way. I did deviate from the metal version of this a fair bit. The metal version was designed where it would actually interlock, which would you'd use the frame as a self-aligning fixture to drill through the spotted holes and then tap into the frame for the final assembly. But for ease of getting this prototype done, I decided to just forego the interlock and I'll just hand align everything, which really it won't matter in the end. I just thought because we were doing the aluminum one, it really needed to be dead on accurate, so doing that interlock was the best option. Alright, now I'm going through and just adding some radiuses to all the hard lines that I laid out, which should give it a little bit nicer of a flow. And then I'm going to lay out some relief holes in the backside. Basically, I wanted a little ventilation around the power supply, and then also there's an access hole for putting in the USB into the controller without having to undo everything. And now it's all done, we're going to start breaking out the skill saw. And I'm just again cutting everything in, just stopping a little short on all the radiuses, and I'll come back with the reciprocating saw and take care of that, and just plunge cutting a couple of these recessed holes, because it's a lot easier to make straight cuts with the skill saw. Like these holes, that there wasn't enough path to actually get the blade to do a full plunge, so I had to come back in with a drill and spot the holes bigger. But you'll see that here in just a moment. I will be going through and taking the little drum sander on my Dremel and cleaning up the inside of these little radiuses. When I used the reciprocating saw, I just kept everything a little bit short of where it needed to be, so I had some material to remove to make a really nice clean radius. And now here we are, we're drilling some access holes so I can plunge the the reciprocating saw blade down in, and just working my way around this whole assembly. And here we are.
All right, well, here's a quick preview of what the frame's going to be. It's going to have 2 rails running through here, and like I said, there's not a whole lot of extra room in this design. It is about as tight as it can be, just because I didn't want to make a giant printer if at all possible. But yeah, there's just no extra room for anything in this one. It'll have a couple, or a triple stack of MOSFETs that sits right here. They'll have dueling power supplies just stacked up there. Dueling beds that are on the same chassis. And all the power connectors are going to run right in through here. Probably have a drop-down chain that feeds all that, so that way it's not just loose wires hanging. Controller's going to sit here. All the Z-axis and the X-axis gantry is going to hang off of this plate here, all this being stiff, and then we'll have the Z-axis will run right there, and then on the back side over here there'll be a belt tensioner system, and this hole right in the middle is actually so you can slide the bed into one position if you need to make major adjustments or take the whole carriage loose from the belt system. You can take it loose right here and do whatever you need to do without having to remove the beds, because once they're dialed in, they're gonna be difficult to dial in, and once they're dialed in, you're not going to want to change them. So, but that's where we're at. I goofed in my calculation. This is off by 50 millimeters, so I'm gonna have to shoot that over a little bit. Not the end of the world. Deal with that in another motion. So I think what's next is I'm going to have to take and sand all these radiuses down, get it all prepped, glue and nail it together, install everything, pull everything back off, stain varnish it, and then go from there. So yeah, I haven't decided what I'm going to do yet. It's a little warm out here today, so I'm going to call it a night, and till next time.